What if I told you that time travel isn't just sci-fi, but something that might actually be possible according to real physics? Not in a million years, but right now. Now you may be thinking, is time travel actually possible? Or is it just a cool concept for movies and late night debates? We've all seen the movies, someone hops into a machine, hits a few buttons, and boom, they're chilling with dinosaurs, dueling with knights, or skipping around the year 3000. But what does the science say? Is there any real-world possibility? Let's dive into what physicists actually think, and trust me, it's stranger than fiction. Let's start with the part that's not controversial at all, traveling to the future. Here's the wild part. You're already doing it. Constantly. You're moving forward in time at a rate of 1 second per second. That's the default. But physics, specifically Einstein's theory of relativity, says that we can change that speed. How? 2 ways, with speed and gravity. According to Einstein's special theory of relativity, the faster you move through space, the slower you move through time. At least from the perspective of someone standing still. It's called time dilation. So if you hop on a spaceship and cruise at near the speed of light, time for you slows down. You could travel for what feels like a few hours, come back and find that decades or even centuries have passed on Earth. Einstein's general theory of relativity adds a twist. Gravity also slows down time. The stronger the gravitational field you're in, the slower time passes. That's not just a theory, it's been confirmed with super precise atomic clocks at different altitudes. Now take that idea to the extreme, like hanging out near a black hole, one of the densest, most gravitationally intense places in the universe. Time slows dramatically there. A few hours near the event horizon might equal thousands of hours on Earth. So yeah, future travel, totally real. Okay, but now let's talk about going back in time, and this is where things get super tricky. Physics doesn't say it's impossible, but the more you dig into the details, the messier it gets. Some of the earliest ideas come from general relativity, which allows for some bizarre shapes in space-time. One idea involves a massive, infinitely long rotating cylinder, spinning so fast it twists space-time around it. In theory, if you orbit it just right, you can end up in the past, and this leads us to the idea of closed time-like curves. A closed time-like curve is basically a loop in space-time that lets you return to your starting point, including the same time you left. Imagine walking forward in time from your perspective, but space and time are so warped that you eventually arrive before you left, like a loop in a timeline. It's a mind bender, but general relativity allows these kinds of situations under certain extreme conditions, like enormous mass or energy warping space-time in just the right way. Einstein was deeply unsettled by this possibility, but researchers kept exploring it. And in the 1980s, scientists like Kip Thorne and Igor Novikov seriously investigated how this could work in reality. Now we hit the big problem, paradoxes. Let's say you send a billiard ball back in time and it knocks itself off course in a way that prevents it from ever entering the time machine in the first place. That's a paradox. Or the classic, you go back and kill your grandfather before he has kids. If you succeed, then you're never born. But then how did you go back in time in the first place? These paradoxes make physicists nervous because they violate something we deeply rely on in science, causality. The idea that cause comes before effect. If we can change the past, then what stops you from unraveling the entire timeline? Despite the paradoxes, researchers have explored how time machines might theoretically be built, at least on paper. One of the most well-known concepts involves wormholes, essentially tunnels in space-time that connect two distant locations. They're a real solution to Einstein's equations, although we haven't found one. If you take one end of a wormhole and move it really fast, say close to the speed of light, and then bring it back to its original location, time on that end will have slowed down relative to the other. Now the two ends of the wormhole are out of sync. Step through one and you're stepping into a different time. Another method, put one end near something with extreme gravity, like a black hole, and leave the other in normal gravity. The end near the black hole experiences slower time. That creates a kind of natural time offset. Here's the problem with most of these ideas though. They require negative mass or negative energy. This is exotic stuff that, as far as we know, doesn't exist in usable form. It's like needing a material that falls upward. It's allowed by the math, but nature doesn't seem to work that way. Without it, wormholes would collapse instantly under their own gravity. You'd never make it through. There are some strange quantum effects like the Casimir effect, where negative energy appears to show up briefly at tiny scales, but we're nowhere near the kind of stable, large-scale negative mass you'd need for time travel. There have been attempts to design time machines without negative energy. One promising idea came from physicist Caroline Mallory, who worked with her advisor to design a system with two parallel cars made of normal matter. If you accelerate one incredibly fast while the other stays still, a time loop, like a closed Timelike curve, might form between them. No negative mass needed. But here's the catch. To bend spacetime enough, each car would need infinite density, basically a black hole inside of a car. So yeah, that's a hard pass from the laws of physics for now. Stephen Hawking, the legend that he was, thought that the universe itself might prevent time travel. He called it the chronology protection conjecture, the idea that physics steps in to block any scenario that would let you mess with the past. Why? To preserve causality and protect the timeline. It might be why we've never met time travelers. If they could come back, wouldn't we know by now? Now here's the really deep question. Even if time travel to the past is possible, can you actually change it? Some scientists and philosophers argue that the timeline is always self-consistent. So if you try to do something that would change the past, like kill your grandfather, something will always get in the way. Not because you're magically blocked, but because you'll fail in a normal, everyday kind of way. You'll get stuck in traffic, the gun will jam, you'll spill coffee on yourself. This way, free will still exists, but the outcome is always consistent with the past that already happened. In 2020, physicists Fabio Costa and Germain Tobar even did the math to show that time travel without paradoxes is possible, at least theoretically. So let's recap. Traveling to the future? Absolutely possible. We've done it, and we could do more with fast travel or high gravity. Going back in time? Not off the table, but it does come with massive paradoxes, weird physics, and some uncomfortable implications. Building a time machine? We're missing the materials, the energy, and the tech, for now. Maybe the universe allows time travel, but makes it so hard you need near infinite resources to pull it off. So what do you think? Is time travel real? Are the paradoxes too big to overcome? Or is there some hidden part of the universe just waiting to reveal the secret? Drop your thoughts in the comments. And if you enjoyed this video, hit that like button, subscribe for more mind-bending science, and share it with a friend who's always late. Maybe they're a time traveler in disguise. Thanks for watching, and I'll see you in the future, or the past, or whatever.